Welcome to our exploration of quantum computing. I'm excited to take you on a journey into one of the most fascinating and revolutionary technologies of our time. Today, we'll discover how quantum computers work differently from traditional computers and explore their incredible potential to transform our world. Don't worry if you're not familiar with quantum physics. We'll use simple analogies and clear explanations to make these concepts accessible to everyone. This slide introduces quantum computing as a revolutionary technology that harnesses quantum physics principles to process information differently than classical computers. Emphasize that quantum computing isn't just faster. It's fundamentally different in how it approaches problem solving. The key point is that it promises to solve problems that are currently impossible for classical computers, particularly in fields like drug discovery, artificial intelligence, and cryptography. This sets up the foundation for understanding why quantum computing is considered the next major leap in technology. This slide compares classical and quantum computers in simple terms. Classical computers use bits that are either 0 or 1, processing information step by step, like reading one book at a time. Quantum computers use qubits that can exist in multiple states simultaneously, allowing them to explore many solutions at once, like reading multiple books simultaneously. This fundamental difference makes quantum computers incredibly powerful for specific complex problems, while classical computers remain perfect for everyday computing tasks. Think of a qubit like a spinning coin. When a coin is spinning fast, you can't tell if it's heads or tails. It appears to be both at the same time. That's exactly how qubits work in superposition. While classical computer bits must be either 0 or 1, qubits can be in multiple states simultaneously, allowing quantum computers to explore many solutions at once instead of checking them one by one. Superposition is one of the most fascinating aspects of quantum computing. While classical computers use bits that must be either 0 or 1, qubits can exist in both states simultaneously. This is like having a coin that spins in the air. It's both heads and tails until it lands. The light switch analogy helps people understand this concept. Imagine a dimmer switch that can be at any brightness level between completely off and fully on. This capability allows quantum computers to explore many solutions to a problem at the same time, making them incredibly powerful for certain types of calculations. Quantum entanglement is one of the most fascinating aspects of quantum mechanics. When qubits become entangled, they form a connection that transcends physical distance. This isn't science fiction. It's been proven in laboratories worldwide. The magic dice analogy helps visualize this concept. Imagine having two special dice that are forever linked, so when you roll one and get a 6, the other automatically shows 6 too, instantly, even if it's on the other side of the universe. This slide showcases the transformative potential of quantum computing across 5 key industries. In medicine, quantum computers could revolutionize drug discovery by simulating molecular behavior at scales impossible for classical computers, potentially reducing development time from decades to years. The finance sector could benefit from quantum optimization algorithms that analyze complex market variables and risk factors simultaneously. For artificial intelligence, quantum computing promises exponential speedups in machine learning tasks, enabling AI systems to process and learn from massive datasets more efficiently. In cybersecurity, quantum computing presents both opportunities and challenges. While it can create virtually unbreakable quantum encryption, it also threatens current encryption methods. Finally, logistics companies could solve previously impossible optimization problems, coordinating global supply chains with unprecedented efficiency. These challenges represent the current reality of quantum computing development. The fragility of qubits means they lose their quantum properties very quickly when disturbed by heat, vibrations, or electromagnetic fields. The temperature requirements are extreme. We're talking about temperatures hundreds of times colder than outer space. Building larger quantum systems becomes exponentially more difficult as you add more qubits, because each one must be perfectly isolated and controlled. While we have made remarkable progress, with some systems reaching a few hundred qubits in 2024, we likely need millions of qubits for truly revolutionary applications. These challenges explain why quantum computing remains primarily in research labs rather than consumer devices. This slide showcases quantum computing's incredible future potential. Emphasize that quantum computers will solve problems that even our most powerful supercomputers cannot handle today. They'll transform cybersecurity by creating unbreakable encryption, revolutionize AI by processing vast datasets simultaneously, and accelerate scientific research in materials and medicine discovery. The exciting part is that quantum computing power may eventually be accessible to everyone through cloud services, just like we access the internet today. Quantum computing is truly just getting started on its journey to transform our world. This concluding slide emphasizes that quantum computing represents the exciting intersection of imagination and scientific reality. While these technologies are still in experimental phases, the rapid pace of development suggests transformative applications are on the horizon. Encourage the audience to maintain their curiosity about this emerging field, as we're witnessing the early stages of what could be the most significant computing revolution since the invention of the transistor.